Okay. If you remember, yeah, signal and system. I will show you the. So. If you remember this map, this concept map, yeah, that you already discussed last week, I will a bit extend, maybe another, how to say, another way. For example, given a unit sample here, how to express to the Z transform. To the Z transform, I will show you some ways. Yes. Okay. Hope it's wait a moment. Okay. Whiteboard, and then okay, it seems to be I need the big screen actually. Yeah, it's okay. No. Yeah, I use a smaller screen actually. Yeah, for the extension. Okay. Anyway, for example, we have a signal or system function. Yeah. In time discrete domain, yeah, and then we have as an impulse signal, let's say one.
Excuse me, sir. I think the share screen is not showing.
Oh, okay, yeah. Sorry, I'm sorry. Okay, no. So right now you can see.
Yes, we can see it right now, sir.
Okay. So yeah, for example, we have a signal or a system, yeah, as h n in time domain, time discrete domain, and then has an impulse response. So we can draw here as an impulse signal, the value being 1, 1, 1, 1, 1, and so on. Yeah. So using Z transform, we can write as Z, for example, here like this. So we just like delay. So 1 multiplied by Z power by -0 plus 1 Z minus -1, 1 Z minus 2, and 1 Z minus 3, and so on and so on and so on. Okay. So using actually until this step we have done, we finish, and we can say this is a Z transform. But if you want to express to be more complex, yeah, actually you can see here this is like an infinity. If you have right until certain value, also permissible, but maybe it takes space out. Okay, so we want to make it complex, yeah, complex. There is 2 ways. First, using geometry series. Geometry series. Yeah. How to express this one? Actually, if we see here, we can write here, and then we draw as a more compact. Yeah. For n equal to 0 and become infinity, and then this is 1 actually. Yeah. 1 power by n. Yeah. Actually, one power by any value is still 1, yeah. And then z minus n, right? Z minus n. Okay, this is still yeah, a bit compact. And then we can draw become like this, become infinity, and then this is become z power by n, right? Power by n. And this, if you don't consider that this is not complex yet, and then we can to say using geometry series, yeah, this series, because actually this one is a series, yeah. Then you using a geometry series by looking at table, yeah, looking at table, we can draw as one. This is by 1 minus, yeah. So we arrive at z minus 1. Okay. Maybe some of you, how to express from this form to this form? Yeah, actually using lookup table. Yeah, you can search from the internet or from the geometry in using keyword geometry series. Yeah. Wait a moment. Geometry series formula. For easy resource, you can see from the Wikipedia. Oh, Wikipedia. Okay, you can see here this one, for example. Yeah. This one is kind of geometry series, and then you can get actually the point, or the point that we want to express is being like this. It's just a nominator and denominator. Yeah. Okay. Okay. And then, okay, this is using geometry series. But if you maybe a bit confused, or maybe you don't remember how to express in geometry series, there is another way. Actually, this is for fun, yeah, not for yeah, this is not for fun. This is just for fun, yeah. You can see here. So here z hz is equal to 1 plus z power by minus 1, okay, plus z2 plus z minus 3, and so on and so on. Okay. And if this one we can express like this, for example, z minus 1, yeah, it will be equal to something like this, right? Okay, plus something like this. Okay, and then if we divide it by z here, also we will, here is divided by z, right? By z, oh no, by z 1. Yes. So we can write here, maybe I need more space here. Z minus 1 my per Z minus 1. Okay, this is actually will be HZ. Yeah, you can understand this one. I will make a separator here. The separator. Okay, and then we can easily compute become Z minus 1 equal to Z power by minus 1 Z. Okay, and then we can superpose, replace the position, so it's kind of Z. This one become 1 minus Z power by 1 equal to 1. Okay, and then because I need more space, I will put here. Okay, so we can write a Z HC as 1 per, yeah. Okay, and then we get some result actually minus 1. Okay, that's finished. Okay, is there any questions? Is there any questions? Yeah, this is just for fun. If you are interested in mathematics, maybe in something tricky and complex. Yeah, sometimes it is very, how to say, very enjoyable. Enjoyable. Okay, any question anyway?
So I want to ask a question.
Yeah, of course, please.
From HZ equal to 1 to 1 plus Z power minus 1 plus Z power minus 2 and plus Z power minus 3. Below it, I see, can I annotate, sir? Maybe.
Yeah, of course, please.
I don't get this part, sir. The HZ minus 1.
Which one?
Where do you get HZ minus 1?
Z minus 1. Yeah. Why? Maybe you asking why, something like that?
Yes.
Yeah.
How do you get HZ minus 1?
Oh, HZ minus 1. Actually, you see, this is 1, right?
Oh, yeah. Oh, yeah. I
Yeah.
already see it.
Yeah. It's tricky, right?
Maybe I didn't focus yet.
Okay.
I get it.
Yeah, I put this one to the left side, and then we get this one, and then since it's yeah, you can see here in the right side. Yeah, from the right side is also we can how to say, manipulate into some certain form. Yeah, so I decided to all of the part, I mean both side, divided by Z power minus 1. So we can get exactly, after we divide it in the for the right side, we can exactly the edge Z. So something like that.
Okay, sir, it's clear.
Okay.
Thank you, sir.
Yes, you're welcome. So, okay. No question? No question, yeah? Okay, I will clear all this one. Okay, so let's make an exercise as you requested in the survey from the survey. Okay, I have actually xn, xn being maybe 6 power by 9, yes, and un, yes. So find the Z transform. Wow, yes. Okay, please everyone conduct this exercise. Yeah, maybe 15 minutes, yeah. 15 minutes, yeah. Okay. 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 Please conduct the exercise. Okay.
Yes, sir.
Enjoy. Yes. Allow me to this. Okay, and then we can 2, 3 z less than 1, and then it is similar to how to say, it's similar to this one. If we have this is 1, and then no, it is similar to it is similar to this one, similar to this one. So if we get maybe this point, and then so this one is become -3 by 2. See, and then this one should be this one. Three, and for the second term, 2, 3 per z less than 1. So in this time is 3 per 2, and this one become C. So combining two results, we can say as Z greater than 2/3. Okay, something like that. Considering both sides, yeah, considering this one and this one, means that the Z is greater than, yeah, 2/3, something like that. Okay. Okay, and then from this point, after this, we can draw the ROC here. Actually, you can draw the 2/3 because it is works from both sides. This 4 minus 3. This is, we can make a circle. So the region of convergence is outside. Yeah, the region of convergence is outside of, let's say this one. Okay, any questions for determining the region of convergence from Z transform? Yeah. Or still understanding? No problem. Yes, any question?
For this one,
You mean this one?
yeah, does it apply for all Z transport?
Sorry, what?
Does it apply for all Z transforms?
Oh, yes. So we should how to say, actually this, what value in this in bracket with power by n or square by n, and then we can apply using this formula. Is like formula, necessary condition, necessary condition, and then this is we express, it should be absolute in both, absolute, because we apply in negative and positive directions. Less than 1. Why should be less than 1? Actually, this is because for confirming, that the value is convergence. Why we should less than 1? Okay, and then we continue our computation, and to derive or to determine the area which gives the value of Z become convergence, something like that. Okay. Later, if you have any question, please let me know. And then maybe we need to say exercise again, yeah, to make sure your understanding. For example, the xn is still 2 per 3, yeah, powered by n, but u minus n. U minus n. So find the Z transform. Okay, you have another 15 minutes to conduct this exercise. Okay, finish. Some of you want to be a volunteer? Okay, maybe
Maybe I can try, sir.
Oh, Goldie. Okay, please. Goldie, please. And please define the ROC as well, yeah? ROC, region of convergence. And maybe once more, please draw the Z plan. which area that z value converge.
Okay, wait, sir.
Yeah. Sorry.
Like this, sir.
Okay, so which area that value of z converge?
Inside the circle, sir.
Inside the circle. Okay, good. So please a bit explain to us how you derive using this way, and this way, something like that. So I help you here. So the area is here inside. Okay, okay. Please explain it to me or to us. Maybe a bit short.
First step, we focus on the u minus n to define first the transformation. Actually, I get this z power by minus 1 divided by z power minus 1 minus 1 from the internet. So we can simplify this equation to 1 divided by 1 minus c. Then we can after we define this u minus n to the z transformation, we can get all of the xz and will become like this equation 1 divided by 1 minus c divided by 2 divided by 3, and we make it easier by multiplying 2. So we get 2 divided by 2 minus 3z. For the ROC, we can see from the z transformation, and will define like this. Maybe like that.
Okay. Okay. If we comparing this result and the previous questions, if you remember, what conclusion you have? Is that not clear, my questions? Hello? Still there?
Hello, sir.
Yeah, hello.
Wait, sir.
Yeah.
Maybe we can conclude that the difference is on the ROC. Sir,
Yes.
maybe it is inversely berkebalikan, sir.
Yeah.
Karena the value of due to u minus n.
Okay, so you got the differences of them, right?
Yeah.
Okay, good. Okay. Thank you, Goldie.
You're welcome, sir.
Yes, and then yeah, I will make a bit explanation. Yeah, actually from the Goldie's result, that's very correct. Yes, according to the expression of the Z transform and then defining the region of convergence, that's correct. Yeah. I just want to point out, comparing the previous questions, yes, if you remember that the previous questions, the xn, yeah, let's say xn lah, yeah, xn, the previous one, yeah, previous questions. Okay, it is equal to that 2 by 3 powered by n, but the un is without minus. And we realize that so the Z transform here is 1 by, yes, 2 per 3 Z minus, yes. And then for the result also similar, yeah, similar, yeah. Similar. Also the Z transform here also similar, yeah. Similar, 2, 3, Z minus 1 also as well. But the difference is on the ROC. The ROC here, due to the minus, yeah, the minus is inside of this circle. In this case, is Z less than 2 by 3. Otherwise, this one, yeah, this one, the ROC is something like this. Okay, it's outside of the circle. Yes, that's the effect of region. I mean, where is the signal come from, in negative region or in positive region? Okay, so using these expressions, maybe you can easily then let's say we have the xn, yeah, xn being 2 by 3, yeah, and un, yes, and plus maybe 1 by 3, yeah, and u minus n, yeah, and then we can define easily the ROC of this. Actually, the ROC of this is outside, right? Outside, yeah, outside. I think I make a mistake, ya. 2/3 ini di luar, ya. Yang ini sepertiga, which is di dalam. Jadi kalau digabung, this combine, and then there is no overlap, ya. No overlap, yeah. So the ROC doesn't exist. In other words, do not exist, yeah, does not exist, yeah, does not exist. Okay, but otherwise, if we have xn, for example, we change the notation, still 2 by 3 this n, but this is u minus n, and plus 1 by 3, and this is a un, and then this ROC will be exist, because if you remember, I changed the color here, the color, okay, and then for the first part, it's not so good. Okay, wait a moment, undo. Okay, good. So here, okay, actually this one is 2 per 3, and this should be inside. Okay, so I changed the color for the second term. The second term is here, right? 1 per 3 and outside, yes. So it's clear the ROC become donuts. Yes. Okay, it looks good. Okay. We can have a iftar using donuts. Okay, anyway, any question from these explanations? Yes. Everybody got it? Or any question, please? Okay, if no questions, we move forward to the inverse. Inverse. Okay, allow me to express, for example, yes, the xz is equal to, how to say, minus 3z 2z power by 2, yeah, min 5z plus 2, yeah. Okay, and then we can use a partial fraction, of course. First, we factorize this one, so it's become what? It's kind of minus. So so is 2z z, and this one might be minus, yeah, minus 1. No, should be minus 2. This is minus 1. Is it correct? If this one, it should be this one. It is minus 4 plus minus 1. Okay, this is correct. Okay. Okay, it's 2z. Yes, so we got this one. And 2z minus 1 and z minus 2. Okay. And then we got a and b. Okay. Using same way in the partial fraction, so we compute the a is equal to minus 3z per 2z minus 1 z minus 2 multiplied by 2z minus 1, and we substitute here z equal to 1 by 2. So we remove this one and we substitute the half here and become what moment? It's like 3 per 2. and this one is minus, ya, also minus 3/2 ya. Ini setengah dikurangi 2 berarti minus 1/2. Berarti ini equal to 1. Yes. And the B is similar ways. This one and 2z minus 1. Z minus 2, yes. And z minus 2, yeah. And we substitute here z equal to 2, okay. This one and this one we simplify and then we submit it to become what? Become minus what? Minus 6, okay, minus 6 by 2 times 2 4 minus 1 3, yeah, 3. So it is equal to it's finished here. I put here, yeah. I put here is become minus 2. Is correct? Okay. Okay, and then so we can draw here, and then this is 1 2 z minus 1 plus this is minus z minus 2. Okay. Okay, the next step is using lookup table. Yeah, of course. First part, yeah, this one, yeah, this one is how to say, no. This is 2, yeah, 2z, yeah, 2z is like not zz, yeah, like 2z, so it is similar to minus, yes, minus 1 per minus per minus, so 1 dibagi 2z, right? 2z, ya. So it is similar to plus, yes, minus 1 minus ya 2 minus 2 aja lah ya, minus 2 ya, minus 2, so bagi doang. It will be similar to how to say ini, this is dikeluarin ya, bagi 2 berarti minus ini 1, ini bagi 2 berarti berapa ini? 1 dikurang Z per 2 ya. Is that correct? How about this one? Is there any question until this point?
No question, sir.
No question, okay. Okay, so I need to remove this one. Okay, for the A, you got it. So until this point, Okay, you got this form. Okay, you get this form, and then we need to, what to say, look up table. Yeah, actually, it's like this one. The first one is just minus the z. It's equal to, if multiply divided by z. So wait a moment. Easiest ways, we have to look at table. What is the standard form of a Z transform? Z transform. Yeah, actually, fortunately, we have a simple way to, so we can like divide it by z. So we have this one. Z is z minus 2 no. For the first part, the xn is inverse from the first. This is the first part. It's like minus, and the second part is 2. This should be 2, and this is should be u minus n, 2 power by something like that. And the first second part is the xn becomes minus setengah pangkat n. This is u minus n as well. Is correct? So in this case, the xn this minus already, yeah. Ini dikurang ini dikurang ini jadi 2. Oke, setengah n minus 1. Oke, menjadi minus 2 pangkat n dikurangi setengah pangkat n ini minus. Okay, that's all. Okay, if you have any questions, please.
Sir,
Yes.
I have a question. Why is the function u minus n not un?
Not un. Actually, if you remember, yeah, actually this is like if you have do a lot exercise, you will be notified. But actually here like this, for example, is the xn, yeah, the xn is u minus n, u minus n. So for formal formulation of z is equal to minus infinity to the 0, right? Minus infinity to the 0, and this is 1. The z, the formal definition is, wait a moment. Okay, the formal definition from the z is from minus infinity to the positive infinity u minus n z minus n. Is it correct? And then from these expressions, we got, due to the un here, this is from like this, the limits, yeah, the threshold is changed, so it's z minus n, z minus n. So in this case, the z itself, yeah, it's similar to the 0 until infinity, but it's powered by zn, something like that. Okay, until this point, okay. And then maybe I need more space actually, yeah. From these expressions, if you remember that this is Zn, if using geometrical representations, it should be 1 minus z for z less than 1. Yeah, this one. Actually, why the un? If you compare this one, maybe the xn is un, yeah. The xn is un. Xn is un, so the z transform becomes z equal to the something like this, 0 infinity and z minus n, right? Z minus n. And this z minus n will be equal to 1 minus z minus 1. So z minus 1. Yeah, that's correct. Okay, that's the point. Why we need to put minus n, not n. Allow me if there is a still unclear explanations. Allow me now. Okay, any other questions? Maybe if no, I will move forward to the maybe last part. Yeah, last part. So I move this one, and then for example, we will use the z transform for difference equation. Actually, last time we already did, right? Let's say the y and maybe minus y and minus 1 equal to dou n, and then we transforming to the transform this equation into z, yeah, and then become yz. This is minus yz, because the delay is 1, so multiple by z square 1, and this is the z transform of d n is 1. So in this case we have yz equal to 1 minus half c1 equal to 1, and then yz still in z domain, one. And you remember this form is if we inverse to the n, yeah, this is inverse to the power by n, and because this is a negative, z, yeah, it should be n, something like that. Okay, we got the yn become 1 by 2 square and un, something like that. Okay, is there any questions? So because we finished the two topics, Laplace transform and Z transform, according to the course program that I have uploaded at Emas at the beginning of our course meeting. So actually this week is scheduled for quiz, quiz Laplace and Z transform. So in 1 week I will set up the quiz at Emas, covering material for Laplace and Z transform. You can conduct anytime within 1 week, but the duration for conducting the quiz will be limited. And the detailed information will be available at Emas. Okay. Any questions?
Sir, the topic for the quiz is from the Z transform to the Laplace.
Yes, from Laplace to the Z transform. Yes.
Okay, thank you, sir.
Yes. Yeah, not so hard because it's just reminding. Actually, the concept you already exposed in engineering mathematics, and then in this course re-discuss again, but in more detail in terms of signal and system. Okay. So if no question, is there any other questions? If no questions, so we finish our class today. Thank you very much for your attentions. Prepare for the quiz and stay healthy and stay to protokol kesehatan. Thank you very much. See you next week. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much,
Thank you so much,
sir.
sir.
Very much,
Thank you, sir.
Waalaikumsalam. Thank you, sir.